Hi, here is my app calling it the Airport Traffic Monitor. So let's log in as the Predix UA login screen, sign in. So that's my app. That's the Airport Traffic Monitor. It's currently capturing 3 data points. One is the live passenger count and the historical passenger count, and also the prediction number of passengers predicted to enter tomorrow. So the live passenger count is actually counting the number of passengers entering at the airport using Pedestrian Planning smart service, and the historical passenger count is calculating the number of passengers entered in since last 5, 10, 15 or 30 as per the request. The airport security team can use this dashboard and calculate how many number of passengers have entered in last 30 minutes. One thing I forgot to mention, that this dashboard is for the Airport Transport Authority. So they can use this dashboard and check how many people have entered in last 15 to 30 minutes and how many people are currently entering at the airport. It's also capturing another data point, which is the number of passengers near the security checkpoint area by using the indoor positioning smart service. The other graph is the prediction. So for this, I'm using historical data plus many data points plus a sophisticated algorithm to detect how many passengers will enter tomorrow. So it depends on at what time of the year, and depends on what time of the day this data is. So it says that for 1 a.m. tomorrow 59 people will enter, and 2 a.m. 72 people, and so on. Let's see what's the driving factor behind this POC. So that's the use case, white people waiting in security line. So that's the main driving factor behind this POC. If there's a huge wait at the security line, so this POC may help in reducing that wait time. What's the purpose? Purpose is to predict and accommodate the peaks in passenger numbers, and this data will be gathered in real time. So this will help in identifying when to expect more crowd, and then the TSA can take actions for reducing the wait times. Business value is open more TSA gates. So whenever there is a large crowd entering to the airport, then the airport security team can be informed, and they can prepare for extra crowd by having more staff and opening more TSA gates. As soon as a system sees a upper number than a threshold value, then the security team can be alerted. Similarly, airlines can also have a similar dashboard where they can see that if the inflow is upper than a threshold value, then the airlines can also be alerted and they can prepare for extra crowd. That's the high-level architecture diagram. That's the high-level architecture diagram. So the data is being captured from the airport entrances and from the sensors near the checkpoint. For the airport entrances, data is being captured using the pedestrian service API through a WebSocket, and then there is a Java custom class. This now from this class we are sending 2 data points to the dashboard. So one is the live count, which is being directly sent to the dashboard. Second is the historical count. For that we are using GE Predix analytics service and Redis database for store and forward. So in the analytics service we are doing the calculation that how many people have entered since last 5, 10, 15, 30 minutes, and then sending that data to the dashboard. And if there's a number upper than a specific value, then the alerts will be shown on the dashboard. Then using the indoor positioning, we are capturing the number of devices near a specific area, and that area is security checkpoints, and then getting the data from the indoor positioning service and then showing that data on the dashboard. So this shows how many people are near a security checkpoint area. So services used in this POC is pedestrian service, indoor positioning, analytics service, Redis instance, and UAA for security. So that's the POC again. The driving factor for this POC is to reduce the security wait time at the airports. Thanks.